Guys, welcome back. We are finishing up the study guide for Topic C on fractions for Module 5 of Eureka Math, 3rd grade. We were looking at how we use fractions to help us be precise about the lengths of objects using fractions on a ruler. So we have paper clips and we have a ruler that is measuring in inches. We start with 0 on this ruler, and each of the whole numbers are 1 inch. They represent 1 inch. So we have an inch from here to here, an inch from here to here, an inch to here to here. And then in between each of those inches, they have partitioned the inch into 4 equal pieces, or into fourths. Okay, so we have talked and practiced counting at school how to count by fourths, but just as a reminder, in case you're not sure what we have said, we always start with that 0 and we end with one whole thing. Okay, it can still be from here to here, but it's representing one whole unit of something. We look for the halfway mark and we label it as such. That's a half. And then in order to make 4 pieces out of 2 pieces, we partition our halves in half. So I would cut that side in half, and I would cut this side in half, and that gives me 4 equal pieces here. From here to here, the space that represents 1/4 of that inch. The space from here to here represents 1/2 of the inch. The space from here to here represents 3/4 of an inch. And of course, when we get all the way to the end, we have gone an entire inch. So we practiced counting 0, 1/4, 1/2, 3/4, 1. After we get to 1, we count on. So we would say 1, 1 and 1/4, 1 and 1/2. So this would represent the fourth, this would represent the half. And then we wrote that as 1 and 1/2 inches. Okay, when I look at my next paper clip, it actually happens to be the exact same size. Not sure why they replicated that one, but it's also 1.5 inches. Looking at the fourth paper clip, have a 1 inch, 2 inch. It did not make it all the way to 3 inches, so I've got to look at where in there it falls. 2 and 1/4, 2 and 1/2 inches. So I have 2 and 1/2 inches. And then finally this last one. This must be a popular length. Oh, I know now why we're repeating these. I bet we're going to plot them. So we have 1 inch, 1 and 1/4, 1 and 1/2 inch. Okay, I have found the lengths of all my paper clips. Okay, next I'm going to turn it over, and they've given me a part B. Okay, so I know I'm not finished yet. I have to use what I just did. It says use the measurements from part A. Those were the paper clips I just measured to complete the line plot. Now again, they have gone from one side of a paper to another. So here is what I recommend for students to do. I recommend that they look at each one and then they come over. That was 2 inches. I make an X above 2 inches, and then I'm going to check it off over here that I've done it. Okay, the next one was 1 and 1/2 inch. I'm going to come to my line plot. I'm going to find 1 and 1/2. I go above it, the same exact space, check it off that I've plotted it. I have another 1.5 inch paper clip. So I will come to 1.5 inches again, and I will put it above that same spot. Checked that one off. Next is 2.5 inches. I come to my line plot. I look across until I come to 2.5. I make the X above it in the same row as the previous ones that were first. I check it off, and my last paper clip measurement is 1.5. So I come back to 1.5 and I do a third X above that. Some of the things that we've talked about with line plots, when you're correctly recording data, in order to make it organized, you never make an X on the line itself. That line represents having nothing. So to make an X there would be inaccurate. I don't need to represent that there are no paper clips that were 1 1/4. I simply do not put an X there at all. I put all of them in the same visual row as closely as I can, and then I try to make sure that they stay about that same distance apart from each other as I continue to make my line plot. All right, moving on to number 5, it says use the number lines to decide whether each statement is true or false. Okay, here we are looking at an equal sign between two fractions. The word here we use is equivalent. When two fractions represent the same size, they are equivalent. And one of the things that we've talked about is the whole thing has to be the same size. So for example, if this were a brownie that went from here to here, in order to compare, the other brownie would have to be the exact same size, okay? So I would have two brownies that are rectangles the same size and length, okay? Then I'm going to find those fractions. 2/4, I'm going to mark it, and they say 2/4 is the same as, I'm going to move my hand away so it'll focus, 2/4 is the same as 4/8. When I look at where 2/4 fall, and I look, if I were to partition that, 4/8 would be the exact same location. They both are the halfway point. So that statement is true. Next, they said 3/8 is equal to 3/4. I'm going to find 3/8, and I'm going to look directly above it. There is nothing above 3/8 on the fourth side. So then I'm going to look over here at 3/4. 3/4 is actually equivalent to 6/8. They are in the exact same location. So this statement is not true. It is false. Finally, 0/4, meaning I have 0 of my 4 slices if I'm right here. I don't have any slices of that brownie yet, is the same as having 0/8. Those are exactly in the same spot, so that is a true statement. Our last question, question 6, says use the number line from part A and B, complete the number line. Okay, I am looking here for equivalent fractions. So the first thing I have to know is they have put two different partitions or two different fractional units on the same line. Okay, so I'm going to actually grab two different colors here. Colored pencil just to kind of demonstrate this. And we're going to start out with our thirds. Okay, in order to have thirds, I have to have 3 equal pieces. Here, I haven't got any part of this brownie yet, so I'm thinking again about brownies. But when I get to here, I have 1 piece of brownie. From here to here would be 2 pieces of the brownie, and from here to here would be 3 pieces of brownie. Notice that I have 3 partitions of the whole brownie, 3 pieces. That's that denominator, or that bottom part of the fraction. The top part of the fraction represents how many pieces that this point represents. So if I'm right here, I have no pieces of this brownie yet. I have 0 thirds. When I go from here to here, I would have 1 of 3 pieces of my brownie, 1/3. When I go from here to here, I have 2 of 3 pieces of my brownie, 2/3. And finally, when I go from here to here, I have 3/3, or all 3 of the 3 pieces. 3 of 3 pieces is the same as having the whole brownie. I've gotten all the pieces that I made. Okay? They used that same number line to show if we partition into 6. Colored pencils aren't working. Hold on. Let me see if I can get this one to work. Okay, this time, instead of just 3 pieces, we took those 3 pieces and we cut this first third in half. I took the second third and I cut it in half. And I took the third third and cut it in half. If I have 3 things and then I slice those in half, I now have 6 parts total. Okay, so I can take thirds and cut them in half to make a smaller amount, which is sixths. From here to here is 1/6 of that. From here to here would represent 2 of my 6 pieces. From here to here would represent 3/6. From here to here represents 4/6. From here to here represents 5/6. And the final piece would be all 6 of the 6 pieces, representing one whole something. Okay? And I forgot to say, but if I start here, I haven't colored in anything yet. I'm at 0 of 6 pieces. Now then, the last part of that, once I can put 2 different fractions that relate to each other, they have a relationship because 3 and 6 are friendly numbers with each other, then I can come down here and answer about which of those are equivalent fractions, meaning they're the exact same amount of brownie. Okay? If I am at that beginning point, I don't have any brownie yet. So 0/3 is exactly the same as 0/6. Don't have any brownie yet. Okay? This one's not complete, so I'm going to skip to the other part that is complete. When I go from here to here, I have 2/6. 2/6 is exactly the same as 1/3. 1/3 and 2/6 are equivalent fractions. They're the exact same amount, 2 little pieces, or 1 bigger piece. Okay, they're the same. And finally, again, I'm going to look at 2/3. So I would go from 0 all the way over here. 2 pieces of the brownie up here would actually give me 4 pieces of the brownie down here. Those are equivalent fractions. So 2/3 is equivalent to 4/6. Basically, students just need to be able to label correctly how many partition pieces it is, and then see where those line up. All right, I hope that helps for today, and happy studying.